In this video, we're going to identify which of these three compounds was our unknown based on the mass percent, as well as calculate out the mass percent of each element in these compounds. So our three possibilities are silver sulfate, potassium permanganate, and ammonium acetate. Go ahead and pause, solve the mass percentages for these and for the unknown sample, and identify which of these three compounds is the best fit. Then come on back. All right, well, first, let's find the mass percentages of each element in our formulas. Sure, we could figure it for the unknown, and as soon as we run across one that matches it, we're probably right, but you never know. You might have oxygen be the same percent in two of these. So we should definitely find what the percentage is for all three compounds. Additionally, let's just find the percentages for all the elements to get some practice. First thing first, what's my molecular mass? If I'm going to figure out my percentages for each of these from a formula, I can use a molecular mass and the mass of the elements in the formula to figure that out. So for my silver sulfate, two silvers and a sulfate, this is going to be 311.8 grams per mole. For my potassium permanganate, it's 158.0 grams per mole. And for my ammonium acetate, it's 77.08 grams per mole. Let's then identify it for each element. Well, for silver, there's two silvers coming in at 107.9 each, which is going to give us 215.8 grams of silver out of every 311 grams total, which would net us a 69.2% silver. If we try to do this for the sulfur, well, the sulfur, there's one in the formula. It's 32.06 grams of sulfur out of every 311.8. We'll find that that is 10.3% of the total mass, which, 32 versus 310, basically a shift of a decimal and a little bit extra. And then there's four oxygens. Well, so 4 times 16 for 64 from the oxygen per formula, divided by the 311.8 total for the formula, will give us a mass percent for oxygen, which is basically double sulfur here, 32 to 64, and so our mass percent looks effectively doubled, 20.5 with some rounding. So our oxygen percentage in our silver sulfate is 20.5%. Let's try this for our potassium permanganate. Potassium is 39.1 grams of potassium out of every 158 grams of sample total, which is going to be 24.7% for potassium. Basically about 40 grams out of 160. 40 times 4 would be 160, so 25-ish percent. That makes sense. We seem on par with our potassium percentage there. Manganese, on the other hand, is 54.94 grams of manganese out of every 158 grams total. Well, that's closer to a little over a third, 150 below, 50 above. So we're on the verge of being around a third. If we divide those times 100%, we'll find that it is 34.8% manganese. As to our oxygens again, well, we have 4 in this formula again, so 4 times 16, there's 64 grams of oxygen in the formula and 158 grams total. 64 divided by 158, we're going to find is 40.5. So basically double the percentage of the other formula, which if we think about it kind of makes sense. Same number of oxygens, but potassium permanganate is about half the total mass of silver sulfate. 310-ish versus 160. Well, 150 doubled, it's 300. So it's about double the weight total for the silver sulfate, but it has the same number of oxygens in both. So half as much in the total means I divide by half as much, which means my percentage will be twice as big. So this seems to be making sense. We got about twice as big a percentage of oxygen in our potassium permanganate than we did in our silver sulfate. Finally then, let's look at this for our other elements. Well, let's start with nitrogen. I have 1 nitrogen in this formula, so it's just 14.01 divided by the total, 77.08. What we'll find is that nitrogen, I'll put these below here, is about 18.2%. If we want to do this for hydrogen, well, there's hydrogen in multiple sources, but there's still as many in the molecule. If I have twice as much of this, I'll have twice as much of each element. Ammonium acetate has hydrogens in different locations, so sometimes it's written separated out. There's really 7 hydrogens here. Well, that's going to be 7 times 1.008 divided by 77.08. Times by 100, and we'll find that the percentage of hydrogen is 9.15%. Which, yeah, 7 times 1 is 7. 7 divided by 77. Well, that's about 1/11th, which 9.1% is about 1/11th. And so our hydrogen makes up about 9% of the total mass. The fact that it comes from 2 different parts of the molecule is irrelevant. It's all there together in the molecule, and that ratio is going to be maintained, so I can just look at the total amounts of hydrogen. Continue this with the carbon. There's 2 carbons in the whole formula, and so this will be 2 times 12.01 divided by our 77.08. So 24 divided by 77, we'll find that the carbon is 31.2%. Well, the only thing left is the oxygen. We could add it up and subtract it from 100, but just to check, there's only 2 oxygens here, so 2 times 16. It's going to be 32 grams of oxygen over 77. It's a little less than half. 35 doubled would be 70, so we're a little lower weight on the top, a little more on the bottom. So it's going to be a little bit less than half. And sure enough, our oxygen is 41.5 when you divide that. Well, this means 2 of our oxygens are somewhat close and 1 is pretty far away. If your values are too close, inaccuracies in the actual measurements of our sample could leave it uncertain. So let's see which of these it is closest to. I have 25 grams sample and 5.125 grams is oxygen. So 5.125 grams of oxygen over 25 grams total for that sample. This comes out at 0.205 or times 100%, 20.5%. So 2 of our unknowns actually had fairly close oxygen percentages that might have been hard to distinguish, but luckily our samples showed that it was pretty clearly silver sulfate. It didn't fall anywhere near 40%, so it's probably not potassium permanganate or ammonium acetate.